these last two problems. I think this is the last of the packet. Is that correct? All right. So very first problem, very first one, and then what we're gonna do is we're gonna go over some of the stuff on the homework. So I'm going to distribute this here and here. I'm also going to distribute this here and here. And I realize I have negative exponents, but let's take care of the power of a power first. So this is going to give me x to the negative 14 on top. This is going to give me y to the 21st on top. It's going to give me x to the negative 9 on top. And it's going to give me y to the negative 12. Okay? Everyone feel comfortable with that? Okay, so now I want to go ahead and take care of the negative exponent. So here's a negative exponent, and so is here, and so is here. So I'm going to rewrite these with the exponents so they become positive. So remember when they switch locations, so from top to bottom or bottom to top, the exponents change signs. So I get x to the 9th on top, y to the 12th on top, and then y to the 21st stayed up there. And then I have x to the 14 on bottom. Okay? Yeah. Nope. No, the exponent just goes to the exponent. It doesn't go into the actual letter. Just you multiply the exponents together. You don't multiply the bases with the exponent. Yeah. If there was, like, say, a 2 in there, then you'd have, like, 2 to the 7th. And then 2 to the 7th is 2, 2, 2, 2, 2, 2, 2. But we don't have that. All right, so on this part here, I could do tug of war with the x's. Agreed? Yeah. Who wins, top or bottom? Bottom by 5. But I'm not doing a tug of war with the y's. And the reason is
that it's only one y on bottom, which is basically 0 bottom.
Yeah. How many y's are on top? 33? Holy crow, that's a lot of y's. So that's that answer. So I have to make sure I combine those together. Seem okay? All right. Let's finish this last problem. Before I do anything, I'm going to move this location. So I get 8x squared, y to the 3rd, times 2y to the 11th. And it's actually all over x to the 10th. Okay, looks like I can combine 8 times 2, and I'm going to get 16. Tug of war with the x's. Who wins, top or bottom? Bottom by how many? 8. And then the y's get combined. So how many y's are on top?
14.
14 is correct. Okay, so that is the packet completed.
I have a question.
Yes.
Say that I have a problem which is 16y negative 16y, and the y to the negative 16th power. Sorry, I can't talk.
It's okay.
Multiplied x to the 15th, negative 15th.
So something like that?
Yeah.
So everything was negative exponent?
Yeah.
So these right now are numerators, because technically those are all over 1. Mm-hmm. So you'd wind up with an answer of x to the 15th, y to the 16th.
So you just have 1 over?
Yeah. So 1 becomes the placeholder in math, right? Yeah. So there has to be a 1, because technically there would have been a 1 sitting out in front of here, but we don't necessarily write it. Okay, so I wanted to take a look at EEF 3 and see how we did with this one. I know I asked you just to start it. I didn't ask you to finish it. So, and I gave you the odds, yes? So let's take a look at number 1. It says that the speed of light is 186,000 miles per second. That's fast. Okay? So I want to make this in scientific notation. Okay? So I want to make it in scientific notation. So scientific notation, we'd have a number followed. So notice I have this little squiggly line. Some places want you to take it out 3 decimal places. Some say 2 is fine. Okay? I think that we could satisfy this. So right now, the decimal to this problem is sitting right here. So I would like to make it 1.86 times 10. Okay, so I'm going to go 1, 2, 3, 4, 5. So 186,000 is 1.86 to the 5th. Okay? It stays a positive exponent because you're talking about a large number. Yeah.
So we always times 10.
Yeah, it's always times 10. You want to know why it's times 10?
So you can do that for
No. You want to know why it's times 10? We have 10 fingers and 10 toes. That's why we do everything on a base 10. It's because we have 10 fingers and 10 toes. That's how math started out. I got this many and this many. Let's call these things. It's 1, yeah, up to 10 fingers and toes. All right. Now, number 3 is kind of goofy, and this is probably old data. It says that a microchip holds 2 raised to the 64th bits of data. That is 2 times 2 times 2, 2 times itself 64 times. That's going to be a big number. Okay? So, I'm not really worried about putting this in scientific notation because it's already written as an exponent. I would be good just keeping 2 to the 64th as 2 to the 64th. In no way, shape, or form do I think that you need to go and do 2 to the 64th power and multiply it out. That's ridiculous. Okay? Number 5 says credit card interest per day is 1.3 times 10 to the negative 2. And we want to write this as a true decimal. Well, because this is a negative sign, that means in order to move this into decimal, I have to move the decimal 2 spots. So I'm going to go 1, and I got to put a 0 in place. And it's kind of seems strange that you put a 0 out in front of something. So I go 1, 2. So it's 0.013. That's how you would write 1.3 times 10 to the negative 2 back into a numeric thing, not scientific notation. Okay? All right, so I want you to make sure, and the nice thing is you're getting credit for this, being that you're here. If you're not here, hopefully you're watching the video. All right, so I am going to take this, and I want to take care of it. How do I simplify this so I don't have an exponent outside? Distribute it. So does everyone feel okay that there's a 1 right here?
Yeah.
So that's going to go that times that times that. So I get x to the 6th, y to the 3rd, and we're all done. Okay? Problem number 9, done the same way. V to the negative 2 to the 3rd. So yes, we have a negative exponent, but let's take care of multiplying first. So I get v to the negative 6, which, Maddox, you had asked about this kind of situation. That becomes 1 over v to the 6th. Because v to the negative 6 right now is sitting as a numerator, so technically this was over 1, so it just moves down. And there's technically a 1 out front. That's what's taking place. Number 11 is 3 over 8, and it's raised to the 2nd power. So I'm going to put that here, put this here. So I get 3 to the second and 8 to the second. These are both numbers that you could easily figure out. 3 squared is 9.
64.
And 8 squared is 64. And then does 9 over 64 reduce? No. There's my answer. And problem number 13 is x to the 4th over y to the 2nd raised to the 5th. That outside exponent gets multiplied to all the exponents. So I get x to the 20th over y to the 10th. And that's all done.
Can you reduce that?
It can't reduce because x and y are different bases.
So you can't reduce the 20 and 10?
Nope, nope, nope. Oh, that's a great question. No, because we have different bases, those 20 and 10s, they're not like terms. Any questions on these 4 problems? Is there anything I did up there that you have a question about or a concern about? May I move on, friends? Problem number 15 is x to the negative 1, y to the 5th. This whole thing's raised to the 3rd. Yes, I do have a negative exponent, but let's take care of the power to the power first. So I get x to the negative 3, y to the 15. This wants to move. So I'm going to get 1 over x to the 3rd. Y to the 5th stays down there and on the bottom. Why does y to the 5th stay down there? It is not a negative exponent. It does not want to move. A lot of people want to just flip that whole problem over. And it's like, well, be careful. The negative exponent is the only thing that wants to switch its location. And then problem 17, we have x to the 4th, y to the 5th, x to the 7th, y to the negative 2, and the whole thing is raised to the negative 3. All right. We've been taking care of power to a power first, so let's go ahead and do this. This comes here, 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 and here. So I get x to the negative 12, y to the negative 15, x to the negative 21st, y to the positive 6, because negative times negative is positive. So with that, all the negative exponents are going to switch locations. The y to the 6 on bottom is going to stay down there. Okay, didn't have a negative exponent. All right, so I'm going to get x to the 21st on top, x to the 12th on bottom, y to the 15 on bottom, and y to the 6th. Well, I could do a tug of war with the x's. Who wins, top or bottom?
Top by 9.
Top by 9. What do I do with the y's on the bottom? I just add them. Those are just added together, so I get y to the 21st power. Is that okay, my friends? And my favorite problem, you will surely definitely see this type of problem. I have x to the e, y to the pi, x to the phi over x to the phi, y to the e, z to the pi. And it's all grouped together and it's raised to the 0 power, so this has to have an answer of just 1. Okay? This is a problem that shows up on the ACT. It looks so ugly when you get to it, and it's the easiest problem to deal with. As long as you recognize something that is raised to the 0 power has got to be 1. That's the only thing, and it has to do with logarithms. Yeah. Tuesday, a week from today. Is that all right? Cool. Nope. Well, I think it's just a quiz. I don't think it's, because it's not necessarily the whole chapter. In traditional years, when we would have met 5 days a week every day, we would have had covered about a third more material. So we would have finished this chapter, but this is just a quiz. Okay, my friends. How do you feel? So what I am going to give you the opportunity, you have the rest of the period to work on this, is we're going to do EEF number 4. I would like you to do 1 through 7 odd. And then I would like you to then flip to the back side and do 17 through 27 odd. If you need a picture of it, come on up and get a picture. But you have the rest of the period to work on it. If you owe me something, I will give you this opportunity right now to be working on it if you'd like. So let me just get this, hang on, let's freeze that.
Wait,
Freeze.
is it on Schoology?